Tech Will Save Us, edition 2. Welcome if you're watching us on the live stream. Welcome if you're watching us on YouTube. Hope you've got some popcorn ready to go, or a drink if that's your thing. So we had a really great session last month. So this is the second edition, and we got some really good feedback as well. So let's go through the lineup for this week. We have Mike Hoye.
Oh, I'm starting.
We have sorry, we have Mike from Mozilla. Mike, hi. We have Eugen, who is from Mastodon, is the creator of Mastodon. Why don't you say hello?
Hello.
And we have Neil, who has been working on Dendrite for the last few months and is actually making some massive progress on it, and is going to give us a really cool demo a bit later on. So hi, Neil.
Hello.
Cool. So without further ado, and I should say, of course, I'm sure everybody watching the stream will recognize Matthew and Amandine. So welcome very much to them as well.
We're just here to heckle and to ask questions and generally hang out and be a kind of token audience.
I like it. And I also like the fact that you've got extra Matrix logos.
Always.
Yeah.
I guess you've got your Open Tech Will Save Us hat on, Ben, whereas
exactly.
We've literally got Matrix flags flying in the background.
I like it. We've got four Matrix logos. All right, so I'm not gonna waffle on. Why don't I say hello to Mike, and Mike, you can introduce your presentation.
I am actually still typing this presentation in as we speak, and so I may end up trailing off at the end of it, but I hope you'll bear with me. Let me see if I can actually get this thing to consent to present. And let's see. Here we go. Here we go. I'm sharing my screen. I should say that this is the first time that I have done any use of Jitsi for a meeting, and I'm pretty pleased so far with how it's going. Let me just jump back here.
That's open technology for
you. Yay.
Amazing, it works.
I will level with you. I have been using open technology for a very, very long time, and that has not uniformly been my experience. But we're living in a better time right now than we were once upon a time. The last time I tried to make a presentation using purely free software, the video drivers talked to the splitter between me and the actual projector and decided that the only resolution that this monitor would support would 320 by 200. So it then resized all of my screens to be 320 by 200 as well. And I was standing in front of a crowd of about 300 people having to reboot because my computer refused to talk to the projector. That was a long time ago. And I've got to tell you, if you can see this at all right now, it's going much better than it was. So this talk is brand new. It's a little bit abstract, and it's based on an introduction that you've probably seen before. If you've been a longtime viewer of tech blogs, you probably remember when Steve Yegi posted something about the kingdom of verbs, talking about Java. And that sort of inspired this talk. His work has inspired this talk, at least that post did. And this is from, of course, Alice in Wonderland. Talking about the nature of language, and it sort of leads up in a fairly circular way to, I think, a core problem facing not just federated technology, but the idea of federation and a lot of the principles that are underneath it. And so I hope you'll bear with me on the way there. This is sort of what I want to talk about. There's the broad strokes of the talk of what great things programming is, the feeling of programming and the gift that it gives us, and then the constraints that has put on us as well, often inadvertently and often, I think, subconsciously. And what's next, I think, for federation and federated technologies as not just as a set of technology stacks, but also as a movement and as an ideology. But there's another thing that I have to talk about, and that is why all of this stuff ultimately matters. I am, you may know from long-standing posts that I was, during the Matrix transition, the transition of Mozilla, I should say, from IRC to Matrix, I was strongly opposed to federation as a hard requirement for a bunch of different reasons that I'm happy to talk about. And we're going to talk about some of those reasons here as well, and why I ultimately came around on the subject. And this is going to be an important part of it. But I want to open with a question. Some of you might have been asked this, some of you haven't, and I've enjoyed this question because when I ask it in front of classrooms full of undergrads, I ask them, this is the raw material that you deal with day in and day out, every single day of your careers. What would you say it is? And if I'm lucky, I will get 20th of the students tentatively put a hand up, right? Because it's something we don't often think about very often. We think about these things as being code, that we think about them as being stuff that we implement. I'm not going to take a show of hands here because I can't see anybody on this stream, obviously. But not a lot of people take the time to consider what the nature of this raw material we work with every day is. And it's really important that we do, because it turns out that, like a lot of things in this industry, our foundational assumptions matter a lot. Our basic assumptions about what we do and what our values are and what we work with end up having a profound impact on the final product that we shape. And this is what software, I think it's safe to say, is, right? This is an idea that we turn through a set of value judgments into a working machine. And it is not like anything else in the world. It's not like any raw material. I should say it's almost not like any raw material we have worked with in the past. There are very few exceptions to that. And those exceptions are important to recognize for what they are, right? Because there's a handful of other things in the world that are ideas that we've turned into machines, right? And a lot of the same risks, a lot of the same dangers, a lot of the same strengths and powers that you get from those other systems of intellectual engines end up applying here, right? But the most important one for our purposes is this. This is the great, I think, gift that we are granted as programmers, as people who sit down in front of a computer and get to work with it, right? It's hard to describe, but I can tell you from any amount of user research that we have done at Mozilla, it's hard to describe how rare it is for a human being to sit down in front of a computer and feel empowered by it. Like they can sit down and that is not a constraint. It's not just a tool that they use. This is a thing they can use to change the world, a powerful tool they can use to communicate with friends, to communicate with, to do their jobs, but more importantly, as an expressive tool. And that's an extremely rare gift that we're given as programmers. And this is important, I think, because that agency is one of our fundamental assumptions when we're talking about why people care about open source software, why people care about open source operating systems, why people care about federation, right? The answers to those questions often come down to this notion of personal agency, right? Having control over your data, having control over your computer, not being beholden to somebody else, right? This idea of freedom that it gives us, right? That free, as in freedom, as we're frequently said, is open source software. And the challenge there, I think, for many of us is that these foundational definitions do not have, like, they also have sort of an ill-considered philosophical underpinning. Like freedom to what? Freedom from who? We should get specific about that, because those assumptions and those implicit questions that we don't ask also end up shaping the way we manipulate software, the way we decide software should work for people, right? And I want to express very clearly that these assumptions operate at a very, very low level of the human language, right? All of these things, and I gave up trying to fill this slide because it turns out there's a trillion social networks out there that all want to describe your interactions with them in some way, and they all have one thing in common, right? Which is, frankly, the problem, right? All of these things have one thing in common, and that is that they're all things. These are all nouns, right? All of these things are things. So, and the act of participating in social networks, federated or not, the act of participating in social connections on, whether it's Facebook or Matrix, or Mastodon, these are, for the most part, almost exclusively, I should say, things. They're items, right? And we would recognize, if we were talking about physical things, why that might be bad. Like, it might be intuitively obvious for me to say, if I came home one day with the back of my car entirely full of 44,000 likes, my wife would say, where did you put that? Why have you done this? Why have you ruined my life like this? Right? I do that with computer parts, and she doesn't quite say ruined my life, but she does want me to stop bringing those things home. But this fundamental assumption is sort of what I mean when I'm talking about placebo architecture. And let me see if I can find my actual notes about this, because I actually do have a slide here. The important thing here is that all of these nouns, right, all of these systems for human interactions that we have built, that are built entirely out of nouns, that is to say, out of the transmission of things, right, it's a proxy often, in the same way that money is a proxy metric for success, right, that religion is a proxy metric often for happiness, right, and all of these things we discover when the chips are down are often not very good proxies for the things that we want, right. Back when I was using Twitter, it turns out by making things the proxy for these human interactions, we end up in a situation where the act of sharing them becomes inherently dangerous. It's almost, in a sense, it's almost weaponized. Like back when I was using Twitter regularly, which like I stopped doing it, and you should all stop doing it too because it's bad. But you may have noticed that once you get more than a certain number of followers, it becomes like a little bit nervous to actually tag someone into a conversation if you don't know them and know that they're comfortable with that. It gets so bad, actually, that the only way to effectively, like people who are very successful at using Twitter, then the most successful Twitter users effectively have to either stop tagging in people at all, because that tagging in is a weapon, or they deliberately use that sharing, right? The ability to share only things on Twitter, only attention as measured in stuff, retweets, toots, hostile people, that becomes a weapon, right? And I think that if we are sticking to those terms, if we are holding ourselves to the idea that the only thing we can transmit around to other users are these nouns, these things, right, then we are, in a sense, forced to retread the failures of our existing technology stacks. Right? I think that's the great disconnect that is facing federated social media right now as a whole, is that it is almost purely this sort of thing commerce as an engagement exercise, right? This is, let me see, what have I notes here? I've lost track of my notes, I'm sorry. A group of friends, and I don't think this is an unreasonable thing to say, but a group of friends is not a group of people who exchange things, right? Or a group of people who pass things back and forth. Right? A friend is not a thing. You wouldn't have your friends if you started to refer to your friend, a friend, as a thing for very long, I suspect. Right? A friend is somebody who helps, someone who you can help, right? Someone who you can, like, a friend is a relationship that doesn't involve the exchange of stuff, right? That's what I think a real friend is, right? So I get emotional about this stuff because it matters. It turns out the software is agency, and one of the things that this means is that our ability to define what the future looks like is, as far as federation is concerned, is not going to have to, must not limit itself to, the exchange of points of data, right? It must not limit itself to the idea that we are effectively, what's the word I'm looking for, pardon me. It can't be effectively, a mercantile exchange, even if the basic unit of that exchange is, in some sense, data. Right? I'm still optimistic enough, and I'm still naive enough to believe that free software actually empowers people, right? That it empowers us to make more choices, to have more freedom, to express ourselves more freely. The challenge that I have is that we build tools for people that might be expressions of what we think, but that don't grant that expressive ability to other people. Let's see, where are we at here? My mouse cursor is all over the place, I'm sorry. Where are we at? So the question I have is, when we're building the next generation of federated technology, and to back this up, because we're in front of, I'm in in the matrix's house right now. And I should say that this is not exclusively a problem. Like I work for Mozilla, this is a problem with the web too, right? We champion the idea that Firefox is the user agent and it is responsible to the user. And all of that is very, very true. But all of this dates to a time when we did not, as developers, make the assumption that there is something other than that. Right? You can make a decent argument that all of these assumptions date to a time when there was the client-server model. You had a terminal with one human at the end of it, and you had a service with one human at the end of it, and that we have built our fundamental assumptions around that single case since then. Right? The number of people who share their idiosyncrasies in whatever channel, on GitHub, block lists, and so on, those things are extremely rare, and they're extremely difficult to do. Because often that's not in the interests of, the ability to not treat individuals as specific individuals is very much in the interests of centralized systems, right? It's very much something that those systems depend on to maintain the understandability and controllability of their systems. And I think that as developers of a federated future, that is not where we should set the bar for ourselves, right? The question is not how do we grant users this user agency that we enjoy as programmers, right? It's how can we help people who use our systems find each other and help each other in our context. This is where I get around to talking about Matrix a little bit and why I think that federation via Matrix was not only a good idea, but that the Matrix system is home to what I still believe is one of the most important new ideas in software in the last decade, right? And that is the ability to take a verb, a defensive verb, but a verb of saying, I'm not dealing with you anymore, a block list, and saying seamlessly and allowing other users to say, I respect that decision, I will adopt that decision as well. Right? This is probably the most important thing to happen in social software, I say again, in a decade, because what it means is that it is it is in direct opposition to this idea that people are single individual users. More importantly than being able to engage in a shared amount of defense, more importantly than being able to live on a system where individuals cannot be picked off one by one, right? As endemic harassment is an ongoing problem on the internet. It's an expression that we can have such a thing as a society. Little societies, little common standards, right? For each other in a shared environment, right? And our agency over those common standards, our agency over our safety, our privacy, and our dignity, right? That is what a society is, right? That is mutual assistance in support of a larger goal, right? And I can't say enough about how important it was for us to be able to build that system to be able to shift over to a system that granted agency to users like that. Let me see, right? Software isn't society, right? It's just not, right? Our software mediates society. We talk to each other through society, but maybe that's not a bad thing, right? Maybe that's not a constraint. Maybe if we really believe what we believe about open source and user empowerment, then maybe we can take our designs to the next level, take federation as a concept to the next level, right? And talk about how this social software empowers users, not just users, but empowers users to form communities and empowers communities to support each other, protect each other, and thrive, right? So that's my question for you, is how do we share verbs? How do we let people share actions? How do we let people who trust each other help each other with their decisions in ways they don't need to engage with, maybe not even see, right? But to provide ways for people who care about each other to engage in mutual support, right? In mutual discovery, mutual support, and let them evangelize those changes so that they can find other like-minded people and those other like-minded people can find them, right? This is literally where I stopped editing my slides, like 20 minutes ago. So thank you very much for your patience with getting this this far. I don't really know how to end this. I don't know how to tail this conversation off, except to say that we still believe at Mozilla, and I'm still naive enough to personally believe in the idea of the user agent, right? In the idea of the individual user agency and the idea that software should be beholden to the individual. But I think the question is bigger than that now. And I think the question now is about how can software empower communities, right? How can it allow communities to form, empower them to share resources, share defenses, and share learning with each other in a way that is real and safe and doesn't require us to pass around a whole pile of things, right? And to spend our time only passing around stuff. So yeah, I guess the question I came into this was the theme of this talk. Can open technology, will open technology save us? And I gotta say, on its own, maybe not. Technology is just a thing, right? The code is just a thing. But maybe if we really decide that it should be possible, then maybe open tech can help us save each other. Thank you very much.
Wow, thank you, Mike. It was a real eye-opener in terms of trying to spin the whole thing on its head, to think about them sharing actions rather than just entities and nouns across social media. I guess whether that's federated or decentralized or not, but particularly relevant in our decentralized world. I actually had a question. Sorry, Ben, for completely jumping in and hijacking the microphone, but a question because they were talking about this. I guess it was a conversation actually on Twitter, ironically, earlier, where you were mentioning the shared block list support that there is now in Matrix, which is MSC 2313, which basically allows people to define, at the moment, very blunt binary blocks and bands, which can then be synchronized between different rooms and also can be published and subscribed to from different servers. So Mozilla, for instance, is using some of the lists which we maintain as matrix.org and vice versa. And there was somebody, and I'm devil's advocating against myself here slightly, there was somebody out there who responded saying, hey, this is cool and all, but isn't there a risk of people banding together and almost a mob mentality, that it's encouraging echo chambers and filter bubbles to form where if you just blindly subscribe to some block list, then there is a risk that all it takes is for somebody on that block list to start going rogue and adding people for spurious reasons, and before you know it, you've basically got a censorship system. So, I mean, I think that might be the obvious question to pose in response to this.
I think that it's actually quite an uninteresting question, because a set of shared assumptions about what is and is not acceptable, that's what societies are, right? I mean, it's to say that there's possibly a mob mentality there, it's sure, right? I live in a country where we periodically burn police cars because of a hockey game. It's not great, but it happens. But the net benefits of that, like the net benefits of our shared assumptions about the nature of what we believe is right and what we believe is wrong, and the discussions that we have over time as those beliefs evolve, is the important thing, right? The important thing is that individual agency here adds up, right? Not that there is one dictatorial system where someone can effectively cause a filter bubble. I'm going to turn that on its head and say that the question, like that question on its own, presupposes the very early thinking of the internet that all speech is inherently equal and inherently good, right? The nature of free speech as a founding principle of the internet has engendered a great deal of moral cowardice among its adherents in their refusal to make a judgment call, right? And I would like to, and I will argue straight away that, and I will die on this hill, right? That all speech is not inherently valuable, right? All speech is not of equal value, and that it behooves us as members of civilization to make judgment calls about what we accept and what we don't, right? I would like to grant that ability, to everyone, to be able to make those judgment calls. Some people will use that power for, to isolate themselves. Some people will use that power for ill. But God, look, I've recognized that being optimistic right now is a full-time job, but like people are still inherently, despite the amplification tools that the bad people are using, people are still by and large good. And people will by and large still do the right things for the right reasons. I guess I'm naive enough to believe that too.
Fair enough. So Ben, were there any questions from Matrix or your side?
So I think most of the questions from the room really were on the theme of filter bubbles, and how basically how the concept of reputation and shared block lists can lead to this as a high risk thing. But there's also the question, I suppose, of almost the inverse. Well, in that case, how do you find a tighter group of people that is like, what used to be your real friends, a smaller group? It's really difficult. Twitter is the kind of canonical example, but it's an absolute flood of content, and it's really prohibitively difficult for people to find small groups now, I think. And I think that really is the opposite of the filter bubble problem. But yeah.
I'm not entirely convinced that's true. Like, there's an old truism that every single group chat has a second hidden group chat with one less annoying person in it, right? So, and I think that in every case where there are going to be large conversations like this, where there might be a couple of bad actors, there's going to be a second room where the discussions happen, right? And those discussions can happen privately, and when the time comes, those discussions will be where all the discussion happens, right? So I'm still optimistic, right? As long as people have choices about where to talk and what to talk about, I think that these things will, eventually find a way to sort themselves out.
Yeah, I think it's a tricky one because we're basically seeing both extremes happen over a kind of anarchic dystopia where anybody can say anything through pure anonymity and it all goes toxic very rapidly. On the other extreme, you've had blot lists, which starts off looking like a good idea, and then they go toxic because somebody hijacks the bot list and starts putting their own random agenda into it, and you think that you are blocking people based on some characteristic you don't like, and before you know it, it's actually censoring a whole different bunch of people. And I think there's been a kind of knee-jerk reaction against the entire concept of block lists as a result. And I'm not saying that anybody has solved it, as far as I know. We certainly haven't solved it yet in Matrix. But I think it's a really interesting UX problem that you basically need to be able to visualize the block lists that exist and that you're participating in, and hopefully blend them together. I mean, imagine if you could almost have a fail-safe, a bit like a space shuttle system, where multiple systems have to independently agree on the same result in order for the shuttle or the jet or whatever to go in the right direction. If you had something like that, like independent blacklists from different people or grey lists from different people that you mix together and you ignore it unless there's commonality from like 3 independent sources agree that this is an image you do not want to see on your computer, then I feel a lot happier about using that to help filter out stuff from my view of Matrix or Mastodon or whatever it might be, than if it's just subscribing to a single random source and praying that it doesn't go rogue. It's interesting because it really fires people up, but it's a problem we have to solve. Otherwise, all of the decentralized stuff is just going to fill up with nastiness, for whatever your personal definition of nastiness is.
I mean, the challenge is always that automating bad acts is very, very much more difficult than curating good ones, right? But again, I think that there is a possible future here where, as you say, like a consensus. Maybe I say, at least 5 people have to have said that this image is worth looking at before it shows up on my screen, right? Or if 10 people have said that it's not worth looking at it, I'd have to click a button to deblur it or whatever. Because I think that if you have a system where that kind of consensus can be quickly established, you'll end up in a place where people will go, oh, you know what, 10 people said don't look at that, I believe them. Right? So, and if I can choose otherwise, you can go, oh, no, I should have believed them. So,
yeah, I think the important thing is also to make sure that people have actually the right and the ability to override, because that's basically all the recommendation, and at least you can make your own mind, because that's a lot of the problems otherwise, if you're just being imposed with someone else's view, even if you trust them.
Yeah.
Yeah, I mean, in terms of UX, sorry, Matthew, in terms of UX, I mean, Reddit is the most fundamental implementation of that UX because it's just sorting by recommendations.
Except it's morally absolute. On Reddit, there's one great big spectrum of, your Reddit karma or whatever the units are, and you're either a high-quality person or a low-quality person, much like Slashdot or any of the other systems, whereas this stuff is not morally absolute. It's completely relative. So I think the solution is to empower people to track their own personal view, basically create your own view of the world, just like you do in real society. I mean, I think that Mike's analogy in the talk was perfect in terms of the link to real society, that you basically make up your own mind, and it depends who you hang out with and who you want to hang out with. And even if the people you hang out with seem to have gone rogue and being nasty to somebody for no good reason, then you make up your own mind and you override it, like Amandine was saying.
Yep.
So fun as we go and try to rebuild society in our coronavirus dystopia postmodern hellscape online.
I think that we have this, we have the foundational elements of the tools we need are, we have what we need already on the shelf in very many respects. I think that, well, I don't want to say machine learning, because machine learning is a fraud being perpetrated on the engineering community by people with access to large data sets. To be clear about what I think about that. But I do think that the combination of an ability to make a judgment call, to share a judgment call with people who trust you, and who you have either a mutual trust relationship of some degree, and for people on the far end of that to be able to look at that and say, I agree with this, and I continue to share this trusted relationship with this person. I think that all of that is ultimately going to empower individuals to decide what level of shenanigans they want to hit them in the eyes. But it'll also, more importantly, empower the more marginalized members of our societies to put the walls all the way up, right? People who are victims of much worse oppression, all right, and much greater attacks than certainly I am on a day-to-day basis, right? To be able to enact not only defensive measures for themselves and for their communities in the process, so that their communities do not have to suffer the same attacks that they did right away. But maybe more importantly, to be able to do more things like, one of the things that I'm looking at right now or considering proposing is community notifications. Like my group of friends, if I get a notification from, I don't live in the same city as my grandparents anymore. If I get a notification saying that their fire alarm just went off, maybe I would like to share that with somebody who lives down the street who I still hang out with, right? There's a world full of possibilities here where actually sharing our information with each other in some way results in actions that makes our lives better. So anyway, I'm sorry that we're at the 33-minute mark. I don't want to monopolize this talk. We've got a lot of other interesting speakers here.
Well, thank you very much, Mike.
Thank you.
Thank you.
Yeah. Thank you, Mike. Really good. All right, so we've got a double act now. I'm going to introduce Eugen, who is the creator of Mastodon. So thank you very, very much for getting involved with us on the show today. And I think Matthew has put together some Q&A questions. So I think between you can get together and have a chat.
Yeah, I guess.
Yeah.
That's the idea. Hi, Eugen. Are you out there?
Hi. Yeah, I'm here. Quite a different format to the previous presentation.
That's I think it's good to mix it up a bit, and certainly I think we've all been to meetups where it's been like talk after talk after talk, and particularly as we can't split and have pizza and beer and club mate and things in the break between the sessions, I think it's a good excuse for us to just have a chat. And first of all, thank you for agreeing to come on Open Tech Will Save Us and have a talk about Mastodon. We have to say that we're massive fans on the Matrix side of things of Mastodon, and it's almost been a inspiration, I would say, in terms of reassuring us that it's possible to have really nice UX and UI and usability on a decentralized open source project, particularly when so much of it has been put together by one person in the form of yourself. So just wanted to fanboy a bit and say thank you.
That is very flattering. Thank you.
And I think the thing that when we were discussing what to discuss in this Q&A session that came up was the whole problem of running decentralized instances of systems at scale. And it's particularly relevant on the Matrix side because we are infamous for our hilariously overloaded matrix.org public server, which has been on fire for an awful lot, unfortunately, over the last year. We're finally doing some things to fix it, whereas Mastodon seems to do much, much better in terms of keeping its head above water on the larger public instances like mastodon.social. So as a quick starter question, I guess I honestly, genuinely don't know what the infrastructure is that you're using on mastodon.social. What are the tricks that you've been up to keep Mastodon working so much better than Matrix at scale?
Well, the main keyword here is horizontal scaling. Essentially, you've got two ways of scaling systems. One is vertical and one is horizontal. And horizontal is almost always preferable because vertical scaling is very limited. Like it's having to increase the capacity of a single machine, and it only can go so far up. With horizontal scaling, you add more machines to the mix, and that's basically unlimited. So with Mastodon.social, the setup I've got is a lot of different smaller servers handling the load between each other. So there's a load balancer in front of them that handles all the traffic that comes in, as well as TLS termination. There are 4 app servers which handle web requests that the load balancer proxies to them. And there are 2 servers handling background processing. There is 1 database backing it all up, and 1 replica of that database. There are 2 Redis databases and 1 Elasticsearch database. So essentially the principle is we try to split everything that can be split between multiple systems. So the hardest part is the primary database, because sharding is a quite difficult task, and it's especially difficult in software that has to be distributed to lots of end users, essentially, because you can't rely on the admins having the technical knowledge of maintaining such a system or setting it up in the first place. So essentially that is kind of closed off. There's no automated sharding solution that we can distribute. So what we can do is we support replica servers to split the load between one master, which the writes are redirected to. So anything that must update the database goes to the master database, and anything that doesn't require that can go to a replica database, which has basically the same data, but it's in a read-only mode. And that reduces the load on the primary master server. As far as Redis goes, Redis backs quite a lot of features in Mastodon. For one, the home feeds are actually stored in Redis data structures because they're quite dynamic, and they're accessed quite a lot. And at the same time, they're not very persistent in the sense that if a user becomes inactive, there is really no sense in storing that amount of data. So you only want to keep that for people who are actually online. So it's basically a hard cache. So a soft cache would be something you cache on read, and hard cache is something that you update on write. So home feeds, as well as background processing, a lot of things in Mastodon happen not in the request response cycle that the web servers handle, but is instead relegated to background processing because it may take longer and we don't want to hold up the requests, or it allows more concurrency and just, again, splitting the workload between different machines.
And it's like using Sidekick for the background tasks, right? Yes.
And the developer of Sidekick, Mike Perham, is actually on Mastodon as well. So that's flattering.
So in terms of, so you can run multiple master processes, And you say that there is one active writer, but you can have other instances of the master which then read off the replica.
Sorry, I should have probably been saying the names of the softwares and not just database, because it might be confusing. So when I say primary database or replica database, I mean Postgres, right? And when I say Redis, well, I did say Redis, right? Yeah. So a Mastodon. So Mastodon has two modes that it can run in. And one is Sidekick, as you mentioned, which is background processing, and one is Puma, which is processing of web requests. And there is a term that describes the way Mastodon is structured. It's a 12-factor app. Essentially, it means that it is, in a sense, stateless, because you can run as many as you want side by side, and you just give a certain configuration with environment variables, and that controls how it's run. There's no the process itself does not write any data to its own little store or anything. And in fact, when you're running a setup like Mastodon.social, where you have multiple app servers handling everything, you can't even rely on storing user-uploaded data locally, because you've got all these different machines and no way to synchronize data between them. So instead, you basically forced to use object storage like Amazon S3. But we're not using Amazon S3 because that's really, really expensive. Instead, we're using Exascale, which is a Swiss hosting company. We were previously using Wasabi, but not very reliable at all.
So is everything running in Exascale then, or is it just storage?
No, it's a mix. It's a patchwork. Old servers that are under my control are running on Hetzner, which is a German hosting provider. We have our own machines. It's not cloud. It's hardware that we own. Mm-hmm. And object storage is handled by Exascale, and that's it basically. There's only two things.
So how many VMs are the actual servers and services running over on the Hetzner side of things?
I believe it's eight machines. One machine. Well, they're not very cleanly separated between each other, because they started out as one machine does only one thing. But as I had to scale up and more people came in, I was like, oh, I quickly need to install this here to split the load a little bit more. So one machine is handling the load balancer, Nginx, as well as an app server, handling web requests, Puma. Mm-hmm. Then there's two more machines that each run only Puma. Then there's two machines that run only Sidekick, and one machine that runs only a Postgres primary database, and one machine that only runs Postgres replica database. Because among other things, what you get when you have a replica is basically a live backup in case something happens.
And are you doing, presumably there's a lag on the replication to the Postgres replica, or do you not have cache coherency issues between the master and the replica?
They are running in this, I kind of do have to use this thing called, I think it's called feedback mode or something, because I do run into some issues when that's not enabled, where data is updated so quickly on master that queries to the replica kind of have to fail, because the data that they wanted to work with has already disappeared.
Yep.
So the replica basically has to notify the master, I'm running this query, don't remove this data, which reduces the performance a little bit, but kind of what you have to do.
No, it makes sense. And in fact, this is really interesting, because it's I hadn't realized quite how similar the architecture is. I mean, obviously, we run our own Mastodon on matrix.org for our presence in ActivityPub, but I don't think it's set. I think it's set up with basically the default Sidekick configuration for memory. I installed it originally, but more competent people have taken it over since then. And I hadn't realized that there was a scope to actually replicate and use the database slave as a source. We're not doing that currently on Matrix, but we do have the horizontal scaling by workers, but with the catch that there is only ever one single database writer process at a time, and that's where our bottleneck has ended up being on Matrix.
Actually, now that you mention replication and Sidekick in the same sentence, I have to mention that we can't actually use Sidekick with the replica, because the problem is Sidekick starts working on stuff slightly before the replica actually gets the data. So if Sidekick was trying to work with a replica, it will constantly be like, this doesn't exist, this doesn't exist, this doesn't exist. So instead, Sidekick has to be sourced from the master. But as I was saying, so a lot of things in Mastodon are backed by Redis. Redis is a single-threaded server, but it's very performant. It can handle a lot. Still, if you can split the workload, you should split the workload to avoid bottlenecks. So what you can actually do in Mastodon is use different Redis databases for different tasks. So one area where there's a separation is the persistent data, like the Sidekick queues, home feeds, etc. And another area is cache, because we do use Redis for cache as well. Just normal on the read cache of pages and responses and stuff like that.
Makes sense. So how many people is serving on Mastodon.social, and how much CPU and RAM is that actually consuming? Are you running at 100% CPU or 5?
I suggested that question myself and I regret it. I'm not running any of the machines on 100% CPU utilization. They have some space to go up. I think it's like 60%. Most of them are in 60% CPU, and none of them even closely approach the RAM limits, because all of these Hetzner's machines come with like 32 gigabytes of RAM, and even though Mastodon is a Rails application and people say Ruby is memory hungry, it doesn't go anywhere near that. It's 4 gigabytes at most per machine.
Cool. And in terms of the number of humans who are actually using it, I don't know, what sort of metrics do you have? Is it like concurrent or daily active or monthly active? If you can share it, I mean, no problem if you can't.
Okay, so the way we track metrics in Mastodon is if a person logs in once in a day, we mark them down as an active user. And we do this in weekly buckets. So we count the number of unique accounts that have been active within a week. And then, because this statistic is stored in Redis in this, forget what this, the data structure is called hyperloglog. It's essentially a way to count things very fast while also keeping uniqueness, so you don't count the same thing twice. What it allows us to do is to then, from those weekly buckets, also extrapolate the unique active users in a month, which is the very standard statistic that every single social media platform shares, the monthly active users. And .social's monthly active users right now is 42K, but with the same setup, we've gone up to 80K a couple months ago. So that is the confirmed capacity, but it possibly can go up higher than that. There's no telling.
Cool. And have you had any particular disasters in terms of production incidents of things blowing up or saturating, or?
Yes, some things happen from time to time. For example, replication is a quite fragile mechanism. For example, if I decide to run vacuum on the master database. A vacuum is a Postgres command to sort of clean up the database from dead records so that space can be reused by new records. That generates a lot of replication traffic, and that can cause the replica server to just disconnect and give up. And that leads to a very odd, funny bug in the front end, because suddenly the data in the replica is outdated, but the replica still is online. So when, for example, you get an update from the streaming API of a new post, and you click on it and it says the post doesn't exist, because the streaming update came from, it's already pre-rendered in Sidekick, and it comes to your streaming API connection. But then when the client tries to fetch it and that request goes to a replica, it's like, well, that doesn't exist because the replica hasn't received that data because it's disconnected. So that usually requires very annoying process of just recreating the replica from scratch.
I guess it's using WoW replication slots and Postgres.
Exactly. Yes.
Yeah, it's painful. I mean, we have the same thing with Synapse defaulting to or using Postgres, and we have our WoW replicas. And I know I used to do a lot of MySQL replication stuff back in the day, which felt pretty clunky, but it felt a lot easier to reason about than Postgres replication.
Yeah, Postgres replication is an absolute mess. Just to try to figure out how to actually set it up was a nightmare.
Yeah, absolutely. So I had another question, actually. I think this one was from me, because it's a topical one for Matrix, where we're trying to decide how to prioritize outbound traffic. So when you go and send a message and you have full mesh routing, and you might need to relay this out to 2,000, 3,000, 4,000 instances or whatever. If you try to do it all at the same time, you're going to end up with 4,000 simultaneous HTTPS requests, and that could actually use a significant amount of RAM, and it can cause a big spike in memory and CPU and everything. And so we've been looking at ways to try to counterintuitively constrain the number of servers we talk to at any given point, and try to prioritize the faster, healthier ones over the ones which are clearly completely overloaded and are going to sog up resources. And I was wondering if there was any equivalent work going on the Mastodon side to try to...
A little bit of that, but not quite. We don't prioritize servers based on how quickly they respond, although that sounds like a good idea, maybe. I would have to think about it. But we do have mechanisms of detecting servers that are failing, and to try to avoid trying to communicate with them to prevent long timeouts and stuff like that. There's also a mechanism to speed up the process of communicating with servers that I want to talk about. But essentially, when you send a message out, one good thing is that you don't actually have to send it to all the servers in the network. You just have to send it to the followers of the person who posted that message. The only exception is deletes, because we try to make sure that everybody in the network is aware of deletes happening, so that no place has like a remnant of a post remaining after the author has deleted it. So we send the message to all the servers of the followers of the author, and that is usually not such a big number. And we use Sidekick to queue up the delivery jobs. And since a few versions ago, we have this mechanism to use keep alive connections to save time on reestablishing TLS, DNS, and all that sort of stuff. And in fact, it gave us like a 2 times speed up of throughut.
Wow, is that still HTTP 1.1, or is it?
Yeah, it is still HTTP. It's fully compliant with the ActivityPub spec because it's just HTTP. What we do is we keep a pool of connections, and when you've got a server that you're hitting all the time with new deliveries, it means that you can reuse the same connection over and over again and save a lot of time that way.
Mm-hmm.
And then if that connection has been idle for a while, then we disconnect it.
Yeah, no, makes a lot of sense. I guess perhaps the reason why we're obsessing about this is the real-time latency on the instant messages means that we start getting hate mail if there are delays go above a couple of 100 milliseconds or so, which is why we're trying to figure out this particular mess. But I suspect that there's going to be a lot of common research there going forwards. Also on whether there's smarter routing than full mesh is something that we've been looking at, particularly with peer-to-peer matrix, that if every client is running an instance itself, then obviously you can easily have tens of thousands of the things, and doing a full mesh post rather than some funkier spanning tree or whatever is something that we've been looking at.
Yeah, I wouldn't say that Mastodon has any peer-to-peer or meshing technology in it. I mean, it's, for the most part, all communication is direct between, point A and point B.
Yep.
Like if you want to deliver a post to a follower, you connect directly to the server that follower is on and give them the post. And if you want to look up a reshare or boost, then you go and you have this ID of the post and you go to the server the post originates from and you get it from there. You don't pass information on behalf of somebody else. There are very small exceptions. We pass around some public replies to make thread views more complete on all participating servers. So you send a public reply to someone, and that someone's server then redistributes that reply to that person's followers. So everyone looking at that conversation sees like the fullest possible view of that.
Yep. No, it makes a lot of sense. So I had a couple of questions left. Ben, am I allowed to ask a few more questions? How are we doing on time?
Yeah, we're okay for time. We've got another 5 minutes or so.
Okay.
There are a few questions live from the room, but let's see if we can get to them.
I had some from earlier, which were coming in before things actually.
The IPFS one.
Yeah, precisely. So have you ever looked at IPFS for media distribution?
I have actually. I had some hopes for it, but I think in the end it's not really helpful. One misconception about IPFS is that it's somehow free storage, but that is not actually true. If you generate files, then you are responsible for storing them all the same. Essentially, you've got this IPFS node on your machine, and you have a cache of pinned IPFS files. And that is essentially no different than what Mastodon already does. The second problem is deduplication. One promise of IPFS is that because all files are addressed by their hash, that you would not be storing the same file twice or more than once, and that it would somehow help deduplicate across servers as well. But the truth is, if you need to access that file, then you need to download it from the IPFS network, and it's then stored in your cache, which is again on your disk, which is again basically the same thing as what Mastodon already does. And the third problem is that because files are addressed by their hash, you would need to basically always work with files as they are and never change them. And that is not what Mastodon does, because the network we're working with the Fediverse, has got a variety of different servers, and they have slightly different use cases. And not all of them agree on how images or media or files are displayed to the users. So one might have an interface that has very large previews for images. One might have that has no previews for images. One might allow people to share PDF files, one might not, etc., etc. And what Mastodon does is when we work with remote data, we transform it in a format and in sizes that make sense for the way that Mastodon is used and the way that Mastodon apps display that data. One example is we try our best to transform data into formats that are compatible with web browsers so that everybody can view them. That means no WebMs, for example, because WebMs don't work with Safari. So we convert everything to MP4. Well, what this means is that even if you've got the same originating image or the same originating video file that comes from a remote server, if you've got two servers trying to transform that into the same format with the same parameters like size and quality, etc., it's not actually deterministic. So you'll get two resulting files that have a different hash. And that means deduplication between them won't work. So the whole exercise is kind of pointless.
Yeah, I guess the advantage could be that you could offload the file transfer all the way through to the client. If the client is just being passed IPFS URLs, it might not even have to go anywhere near Mastodon or the server at all. But then it's this whole thing, I guess, that you're saying, that your data is effectively mutable, that you want to be able to transcode it to the correct format and the right thumbnail size, etc. And you're not going to be able to do that if you've taken the server out of the loop. I mean, on the Matrix side, we've got the same problem, except it's particularly in our end-to-end by default encrypted world now, the server can't transcode because the server can't see the data. So we've kind of been forced to do all the thumbnailing client side and transcoding client side anyway. So ironically, we probably could use IPFS. And every year for Google Summer of Code, we go and suggest that people do a GSOC project to add IPFS to Matrix. And I think we've done it 5 years in a row now, and nobody has ended up doing it for whatever reason. So it's the same question gets posed to us.
Yeah, I think they're just more immediate things that people want. People are really fascinated with end-to-end encryption implementations, so that's often taking precedence.
Yeah, I would actually love to rework the DM system in Mastodon and end-to-end encryption. I've been investigating this. I've been talking to, trying to get advice from contributors of other open source projects that have implemented end-to-end encryption, as well as some engineers at Keybase, trying to get some advice on how to do it and how to best do it and which model to use, because there's so many different approaches to it, like in terms of key management as well. Because when you've got a casual app like Mastodon, you can't really make it so that everyone has to use their mobile phone and there's like no browser way of accessing stuff. And people have their Mastodon open on an app and on the web browser and then on 5 different computers. So there's all the synchronization stuff as well. And you've got all these different models, like the Signal model, where every device has own keys, the Proton Mail model, where a device generates a key and then it's stored server-side but encrypted with passphrase. And it's difficult, and I'm not really making much progress on that.
Well, I mean, obviously, it's something that we've just burnt many years trying to get right for Matrix, and would be very happy to try to at least talk about it at the cryptographic primitive level. The double ratchet implementation, I
found it very funny when I got the news that Zoom just bought Keybase so that they add end-to-end encryption to them. I wish I could do that.
Yeah, no, it's I guess Keybase are off the market now, for better or worse. But we'd love to help on it, because LibOlm is designed to be protocol agnostic. So the XMPP guys, for instance, use it in Omemo. They originally used libsignal protocol, which is the GPL thing that Signal itself uses, released by what's now the Signal Foundation. But they had some concerns about it being GPL. They wanted a more permissively licensed one, and they also wanted one where the spec was independent of the implementation, which we've done with the formal spec for Olm and MegOlm. So it's there as a way to at least manage a ratchet of keys for one-to-one device-to-device channels. Then if you want to do the multi-device synchronization stuff that you were talking about, we've got MegOlm to go and synchronize the kind of group keys across the devices participating in the conversation, as well as all of the device verification stuff that we've just landed for E2E by default. And that stuff is designed to be picked up by non-matrix things, and is hopefully pretty good now in terms of usability. So whether it's actually encrypting blobs of JSON LD or XML or matrix JSON or whatever is
that's another challenge. completely separate matters. But when you've got encrypted messages that have to be passed from the client directly to a different client, but at the same time, if you want to remain compatible with all these different softwares that are in the Fediverse, you're kind of forced to have the clients write JSON LD.
Yep.
And, you know.
Yeah, it's I mean, it's a big problem, both in terms of where you have different dialects of the underlying protocol flying around. I mean, I guess in Matrix world, it could be, even though a memo on XMPP is using Ohm, and obviously Matrix is using Ohm, in order to, that doesn't mean that magically we have end-to-end encryption between XMPP and Matrix, because you'd have to either be effectively a multi-headed client on one side, talking both Matrix and XMPP, talking through to Matrix and XMPP, or you need to have a bridge in the middle that decrypts and re-encrypts, at which point it's no longer end-to-end encrypted. And yeah, I mean, it's a fundamental frustration and limitation on it, for better or worse. Something else I was going to say about switching compatibility between different dialects. I'm totally blanking on it. You're talking about using JSON LD. No, need to get more sleep. Forget what I was saying.
It's just like from like a purity perspective, it just doesn't feel quite right that you have client developers writing like all this consistent, you know, API stuff, and then suddenly in one area of the code they have to dive into JSON LD and ActivityPub and all that stuff, where they previously haven't needed to worry about that. It doesn't feel very pure, but I don't see a way around that either.
Remember what the other thing else I was going to say, that something that we spent a lot of time getting right, hopefully for the E2E by default in Matrix, was to have Pantalignment as a daemon, which you can run to offload your encryption from the client. So that if you are running some random client software or a random bridge or a different part of the ecosystem that is never in a million years going to bother figuring out how to implement E2E or even adding in an E2E library, instead, Pantalignment is just an HTTP proxy, and it's kind of a benign man-in-the-middle thing that talks the client-server API, goes and runs it through the encryption logic via Ohm and MegOhm, and then just pumps it out the other side. So you can literally talk to it on localhost, and it will proxy you through to where you're actually going to go in order to try to let the longer tail of clients in, to try to fix this fragmentation thing. And so I think it helps with that problem a bit. We weren't sure if anybody was going to use it, but in practice, it does seem to be getting some use, particularly for bots and bridges. If people like had a one-liner curl thing to send a message, the last thing you want to do is to figure out how to do end-to-end encryption on that. So they just pipe it through. But also some of the clients are using it as well. So there's one way
One person in the audience says, why not just use metrics for Mastodon DMs? And, you know, I've had some form of this question, like since the start, like why not use XMPP for direct chats between people in Mastodon? But what does it actually mean? Like, it means that every admin of a Mastodon server has to side by side run a Matrix or an XMPP server and configure that and maintain that, and that somehow these two different software packages have to share their database or data or in some form. Either that, or you just, you know, you just say, well, there's no DMs of Mastodon, just go on Matrix and sign up separately and stuff like that. But that seems like a cop-out as well.
Yeah, it's something that comes up an awful lot. So we had the conversation with, say, Nextcloud, and back when they were doing Nextcloud Talk or whatever it's called now, it was, hey, do they really want to run a Matrix server alongside their existing Nextcloud stuff? Spoken to, I'm trying to remember which of these are confidential and which of them aren't, but basically we've spoken to almost all of the big communication projects and said, hey guys, you should so bundle Matrix alongside, say, Rocket Chat, for instance, before Rocket Chat did their own federation, and they had the same response. And honestly, I don't blame them. They're saying, hey, we've got our server already. You want us to install a whole different server with a different database and synchronize the users just so that we can federate, or just so we can do encrypted DMs or whatever. I don't blame you at all. It makes a lot of sense that that's a pain in the ass. So I think the solution that we're hoping for is to get the Matrix kind of a Matrix server library, or even a Matrix peer-to-peer library, sufficiently small and easy that it becomes like half a meg of code random native library, probably written in Rust, possibly Go, that you can link against if you want to just leverage the matrix sort of communication layer. Even though technically it's going to be some overlap between ActivityPub and matrix, it's probably not much different to having OStatus and ActivityPub sitting side by side in the same system, as I guess you did at some point. And just trying to hide it away and abstract it so that it and have it use SQLite or even in-memory persistence for the state, so you don't need to have this psychological thing of, oh my god, I've got a big matrix server sitting along my same one. Because today, yeah, Synapse is massive, and it would be a huge pain. But with the peer-to-peer stuff we've been doing, where you take our Go implementation, you compile it down to WebAssembly or you compile it down to native code, and that should be small enough that you can just add it into an existing app as a way to get comms. Or alternatively, it's something that the OS can provide as a daemon. So imagine if GNOME went and shipped a matrix daemon as part of the desktop environment, a bit like they used to do telepathy, and then you can just piggyback on top of that for where you want to do the encrypted DM stuff. So I mean, that's the kind of angle we're going at, but it's all complete sci-fi, so I don't expect you to be using it anytime soon. But it would be cool if we can find a way to help out on the E2E stuff there, because frankly, I would not wish the experience of developing end-to-end encryption on anybody else after the amount of time that we've burnt on it over the last couple of years.
Yeah, I'm sure it helped at least to some extent that if you develop the client application as well as the server at the same time, because with Mastodon, most apps all apps are basically not developed by me at all. They're completely independent. The only one that is developed by me is the web app, and that is actually like the hardest one to develop cryptography in, because you can't even really trust cryptography in JavaScript. Yep. So yeah.
Well, it's fun times ahead. Ben, are there any other questions from the audience? Which
there's one here which is a little bit open. Question to both of you, which is, how do you foresee people moving toward federated and open source software, and what reasons would they have for doing that? Which is a great question. I'm worried that it's going to be another hour-long discussion, though. I
think Eugen should go first.
Well, I think it's what Mike Hoye brought up. It's agency. Federation provides people agency, and perhaps not to the extent that his presentation went to with shared block lists and stuff, but the way that you can pick and choose a Mastodon server that has a moderation team and a set of rules that you agree with, and that might be perhaps run by people you trust or an organization you trust or yourself, is a form of regaining agency in social media. And I think that's the primary driver of these things.
I think in the long term, I agree completely with that. And certainly personally, it's why I'm working on this. I'm always worried, though, that it's easy to believe that the rest of the world thinks the same thing. And that if right now I was trying to persuade somebody to come and use Matrix, and I find somebody on the street, not that I'm allowed out of my house, but if I was, and I go and find somebody on the street and say, hey, you should go and use Matrix because it will give you self-sovereignty and an agency and autonomy, I think they're just going to look blank. Whereas if you say, hey, this looks like WhatsApp, except it's better and it's got a few better features, and you almost subversively suck them into the Fediverse and decentralization on false pretenses of actually being a better product and a better app. I think personally that's the way we should get.
Yeah, I agree completely. Ideology itself is not a great driver, because I mean, the ideological part was already there when GNU Social was around, and that didn't really take off at all. And I mean, no wonder it wasn't the greatest piece of software. Just part of the reason why I didn't choose to develop my web client for it and instead started to write my own server. I think many of the things that people mention when they convince others to join Mastodon are actually like the little quality of life things, like custom emojis, for example, or the fact that you can still have an animated avatar, or those things. I mean, yeah, essentially it is you're trying to compete with platforms like Twitter and Facebook, and you have to compete on a feature level as well as the ideological level. Lack of advertising and better moderation are the two great drivers of adoption, as well as the fact that the timelines are not algorithmical in the sense that they're still chronological.
Yeah, I think that I think people probably get more behind the fact that it's not spying on you, and that it's, as you say, it's not an algorithmic timeline. It's more trustworthy in a very almost irrational sense. That if obviously it would be nice if it's backed up with reality, and obviously it is backed up in reality with activity, pub, and matrix, etc. But I can see that also being a real reason to push people more away from Facebook and the like, over towards the worlds of decentralization. And I don't know, I'm just glad that we're at the point.
If I can add something.
Oh yeah, sorry.
I think one more thing is that if you give the user the choice, the ability to choose which app they want to use, because right now, basically you're forced into whichever app the others are using. So if you manage to get enough people building on top of an open ecosystem so that everyone can find the app which actually fits what they need and still allow them to communicate with everyone else, I think that's the other key. Well, so it's not just let's have the biggest and the best features. It's also let's have as many people as possible building on top of it so that they can target very specific use cases.
I kind of have the opposite experience. I agree that in theory, having this platitude of different apps competing with each other should provide a better experience, because you can find a better one and they have an incentive to improve. But in my experience, a lot of people joining Mastodon are asking, well, where's the Mastodon app? And they're really confused when there's a lot of them and no official one. And at the same time, in my own view, a lot of Mastodon apps are unfortunately not as maintained or polished as I wish they would be. So there's that.
Yeah.
I agree.
It's a longer term thing, isn't it? That once you do have a healthy ecosystem like email, for instance, or web browsers, and there actually are thankfully multiple decent competing implementations, and that choice is amazing. But to get to that point, just like in Matrix right now, Riot is very much the most evolved app out there. It's still kind of teething problems, and it's probably not going to be the reason that people jump over today. But hopefully a year or two from now, hell yeah.
There's a couple more questions in the audience. One is about the messages going backwards in history when you're scrolling down. That is not unique to Mastodon. That is present in both Facebook and Twitter and everything. So I don't know. The other question is regarding the earlier discussion about how to scale up the most popular instance. Do you think it is problematic or acceptable and or unavoidable that the various system ends up being highly concentrated? Yeah, I get this a lot. I think to some extent it is unavoidable in the sense that in such a decentralized system, nobody feels truly responsible for yeah, sorry about the sirens. I live by a busy road. Nobody feels responsible for accepting new users, right? When there is a large migration wave coming from Twitter or Facebook, a lot of the servers of Mastodon that are not like my one close their registrations because they don't want to pay to upgrade their servers. They don't want to handle the traffic or the troublemakers that come with it. And they're just fine closing their borders like that. But at the same time, the people that are coming in and are trying to try out the network are not finding anywhere where they can sign up. And so the responsibility of handling that lands entirely on me, because like who else is going to accept those people? Nobody else cares to the same extent about growing the network as the developer of the software that's powering it to some extent. That is one thing. And the second aspect of this is that for people not familiar with decentralization, it can be extremely confusing that Mastodon does not equal Mastodon.social. And because of this, they come to Mastodon.social before checking out anything else. And it can, it's usually, it's basically like a landing area, like an airport where people arrive, look around, and then, if they remain interested in Mastodon, they then become educated about decentralization and create new accounts or create new servers. And that has happened countless times in Mastodon's history, where people who first made their account on .social then continue to create their own server or migrate somewhere else. So it fulfills this sort of important role, but at the same time, I can't talk too much about that because currently the registrations are closed. I've sort of been fed up with lots of people signing up and the stress that comes with it, because it does have a stress aspect with it as well.
I guess our solution on the Matrix side, hopefully, is that one day we will just turn off matrix.org. I dream about it every night, that we will literally just shut down the server. And if we have portable accounts and if we have peer-to-peer Matrix, then somebody installing an app like Riot will just start off with their own server in the app and have total autonomy and agency without any server dependencies. And then if they do want to have a server where they can store their data long-term and make sure that if they lose their phone, they don't lose their conversations, then they can have that as an option. It's sci-fi, but we're getting there. But God, I wish that we didn't have to run matrix.org. And it really upsets me when people say, oh, Matrix is terrible because you have a default large original server. Well, first of all, it's not the biggest one in the Federation, and it's certainly not the best. And my God, I wish we could kill it. I'm conscious that we're running over on time, and that Neil is still hovering in the background, I hope, unless he's gone down the pub, or not that it's allowed to go down the pub.
You better not if he's got to present now.
Cool. Well, are there any last things, Ben, or you?
I mean, there are things. Yeah, it's all small stuff, and I feel like we've gone over it a little bit. Should we say thank you to Eugen? Thank you very much for joining us on Open Tech Will Save Us. It's been really great to see you.
Yep. Thank you so much, Eugen.
Yeah, no problem. Thanks for having me.
Thanks, Mike, as well. All right, so let's see. What is Neil going to talk about? I think he's going to talk about Dendrite, considering that's what he's been working on for the last 6 months.
Has it really been 6 months?
Yeah.
No, it hasn't been 6 months, has it? Maybe not.
6 months on Saturday.
Oh. Yeah, 6 months.
Congratulations.
Wow, that was a guess too.
Right, so with any luck, my screen should be sharing now.
It is.
Yeah, that's correct.
Perfect. So I'm going to talk a little bit about Dendrite, and probably not be quite as long of a talk, but I'd really just like to talk about where we're at. So Dendrite, if you've never heard of it, it's a next generation Matrix home server, and we kind of hope that maybe one of these days it'll end up being the successor to Synapse. It's written in Go, which, unlike Synapse, being written in Python. And the real focus that we have on Dendrite is to solve the scalability problem. So, there's been quite a lot recently about the Synapse guys trying to work through sharding and trying to solve problems basically to stop matrix.org constantly melting. And Dendrite is really taking the approach of trying to fix those problems up front, so that we can scale not only just, not only up to hundreds of thousands of users and doing it horizontally at the same time, but also down to single user embedded home servers as well, because that's going to be just as important if people are going to be, really taking federation to heart. At this point, Dendrite is very developmental, but it does work. And you can log in, you can register, you can create an account, you can create rooms, you can send messages, you can occasionally send invites. So it's still sort of, going back and forward on that one a little bit. But there are quite a lot of features that are missing, so you won't get any end-to-end encryption. Media support is fairly limited at the moment. Room directory sort of half works when it feels like it. But we do have support for all of the current room versions. It does federate with Synapse. If you're in the Tech Will Save Us Matrix room, I'm actually joined there with Dendrite at the moment. And if you saw either of our FOSDEM or the p2p.riot.im demos, then you have already seen Dendrite in action. So why Go? Well, there's really quite a few reasons for this, actually. The first being that the first-class concurrency in Go is just, that is really important for something that needs to scale up as far as Matrix home server does. So we get the ability to spin up Go routines until our heart's content, and we make effective use of resources on multi-core systems effectively. We get really good platform and architecture support. So, if you want to cross-compile Dendrite, it's really easy to do. That's just a property of Go in general. If you want to run Dendrite on an ARM machine that's running Plan 9, you can help yourself. It will work perfectly in theory. And WebAssembly is the other one as well, a really big area of interest for us, which is how Dendrite runs in the browser for the P2P Riot demo, if you've seen that. I believe we've even, in the sort of obscure platforms land, I believe we've even done a customer demo on an IBM Z series mainframe with Dendrite. So anything's possible. We get lots of good libraries from the community as well for managing, things like HTTP routing and muxing. Postgres and SQLite are both really well supported through third-party database drivers. And the last one is going to sound a bit strange, strong styling and linting, but this is something that is really opinionated in Go. And you can pretty much expect that you go to any Go project, it will be formatted the same, the same linters will probably run, the same guidelines are being followed. It makes it easy to know what to expect for contributors, and it keeps us right. It keeps the keeps the code clean, it keeps it readable. So Dendrite is built up of 9 components currently. It's a bit of a microservice architecture, and to be honest, this isn't really a final map of how things are going to look. It's quite likely that we're going to end up adding more of them. And these components communicate using a mix of internal HTTP APIs and also Kafka. We can spin up components for specialized tasks. So for instance, the client API and the federation API and the app service API are the 3 main places where you're going to get events coming in. But you'll note that the sync API is separate because the sync API, even though it's a client job and might fit quite nicely under the client API header, it has additional responsibilities. It's not just dealing with long-lived requests, it also has to actually linearize the room. And it has enough complexity that it warrants being its own component, basically. Public Rooms API and Media API are the good examples. They're things where we want to build a block of functionality and we just chuck it up as a new component. All of these components can run under a single process, which is what we refer to as the monolith. And equally, we can run them on separate machines. We can run it as a polylith deployment. So if you wanted to have the client API, federation API, your actual outward-facing stuff running on a nice demotorized machine somewhere, you can do that. If you wanted to run everything on one machine in Docker containers, just as easily done. And it's really important to mention as well that each of these components has its own storage, where it's necessary anyway. And that's because it helps us to keep really clear boundaries between components. It's easy to really, to actually manage the stuff operationally. You can back up and restore individual components as needed. And if one component misbehaves, it hopefully won't bring down the whole thing, which is, also fairly important from an operational perspective. Something else that I'm going to highlight here as well is that we should be able to scale horizontally in that we could run multiple instances of certain components. So for instance, we talk at the moment about having one giant room server that manages all the rooms, but we could in theory shard that out so that you had a room server per room. Or if you wanted to run, say for instance, multiple client APIs, federation API, sync APIs, you could chuck them behind a load balancer and you can just keep scaling out. Events generally come into Dendrite through the app service API, the client API, the federation API. And more often than not, there's a little bit of work that these things do, and then they shunt them over an internal HTTP API to the room server. And the room server is really the kind of the heart of Dendrite. It's where most things most sort of important matrix concepts are enforced. So for instance, your event authorization and your maintaining the DAG and filling holes and all of those sorts of things, they're all really implemented through the Room server. And we have a variety of patterns there. So we have like input queries where you can just say, here's an event, go do something with it. We have perform queries, which is like, hey, go join that room over there. Or we have query queries where we say, right, the Room server has specialized knowledge about something, about this room, about membership, for instance. Tell me what that is. On the other side, we have Kafka, or Nafka, if you're running it in monolith mode, which is a bit like Kafka, but a bit naff is, I think, what it says in the README. It's a lightweight implementation of the Kafka API, which basically lets us run in a monolith process without really any dependencies at all. And the thing with Kafka is that we can have one-to-many topics. So the Room server can just spit out an output event, and the media server, the sync API, the federation center, and the public Room server can all take a copy of it and do what they want to do. That's necessary, really. Room server doesn't ever communicate with the outside world. This is a really big thing. We do everything that sort of interacts with clients or servers through other components. I've already mentioned a little bit about how the Room server is like the single source of truth, but it's really sort of important to understand that we're trying to make a lot of the other components as simple as they can be. So for instance, the public rooms API doesn't really need to know anything other than here's a list of rooms. Much like the media API doesn't really need to know here's some images, it appeared in this event ID maybe, or possibly this channel. But the Room server is the sort of exception to that rule. It's where we really hone all of our complexity in. It's responsible for managing persistence of events as well. It handles state resolution and conflicts. It works out whether events are allowed to take place or not, which is really important in a system like Matrix where all of the servers are effectively equal players, and then finally it stores them to disk and sticks them out into Kafka so that other components can take them to do work. The Room server does have some quite interesting changes from the model that Synapse uses for storage, though, in that we try very hard to deduplicate everything. A lot of this is down to the fact that everything in the Room server database is associated with a numeric ID, or a NID, as we refer to them as short. So events have NIDs, rooms have NIDs, event JSON have NIDs, the event types, state key type, everything. They're all assignment numbers. And the whole relational model in the database is tied together with these numeric IDs. It saves a lot of precious bytes, to be honest. If you're a large-scale sysadmin, then you might care about the fact that strongly deduplicating everything really will lower your storage costs quite significantly. Likewise, if you go right the way to the other end of the scale, if you're running a single-user Dendrite on a small device like a phone or a tablet or something like that, you don't really want to be wasting storage. So it's a really core principle in the Room server that we deduplicate everything that we can. And this really does matter at every scale. This matters quite a lot with room state as well. So room state contains information like who's at a room, what the, who has power in it, what the topic is, what the name is, all of those sorts of things. And it's very useful in Matrix to be able to recall what the state of a room was at pretty much any point in time. So the way that we do this is that we break state down into snapshots, which can be one or more blocks, and a block contain one or more state events. And we can pretty much look up in the database at any event that we know about and say, right, at this point in time, this state snapshot was in effect, it had these people, the room had 300 people, it was called this, whatever. And that's really efficient in that we only have to create new state blocks or snapshots when we actually create new state. And I have a feeling, I don't know Synapse terribly well, but I don't know that Synapse necessarily deals with this quite as elegantly.
I think that's an understatement. I think that originally Synapse stored a state snapshot every single time the state changed in the room from scratch, and it duplicated the state block over every single state snapshot there was. And that got improved a few years ago, where it now only does a snapshot every 100 state changes. But it's still terrible relative to the compression algorithm effectively that Dendrite's doing here.
Yeah, and we don't really need to worry about doing anything in blocks of 100s or anything like that, because we're compressing basically all of the time. I can actually show you that in action a little bit, because I do have the database for my home server open here. So you can pretty much see in these columns, there's all sorts of NIDs. So latest event NIDs, last event sent NID, state snapshot NID. So we can take this one here and say, right, this particular snapshot NID 202, go over here, filter on 202, whole filter out. So that has one state block, 197. Type might help. This is where we find that trying to query the database is, oh, there we go. It's found 8197 instead. But you can see the same principle. The state block NID 8197 has a whole different bunch of event state key NIDs and event NIDs. I'm willing to bet that this is probably matrix HQ, because it's got, I don't know how many different numbers there. And then from the event NID, you can go and look up what the actual JSON of the event is. So it's sort of very separated out in that regard. The other component that's sort of fairly interesting to talk about at the moment is the federation sender, which pulls in events from Kafka. And I've recently redesigned this and rewritten quite a bit of it so that it's a highly concurrent design. It's really important in Matrix, when you're in a room that's got hundreds of servers potentially, that you can send out events without it feeling slow, without it bottlenecking on servers that might be slow, without it bottlenecking on servers that might have just disappeared altogether. So we really need to have strategies to cope with federating with lots of servers simultaneously. So the new federation server will actually do most of this in the background. It just plucks events out of the Kafka stream, which the room server sends to us, and it chucks them into a queue. And each remote server has a queue, and each queue is processed individually. We can back off individually on any server if they're returning errors to us. So we can say, right, they returned a couple of 500 errors. Let's give them a little break, give them a few seconds, try again. If that fails, we can try that again. And this all happens just individually within one queue. If we keep retrying and we find that actually they're really not playing ball at all, we can just blacklist the server. And that doesn't affect the operation of any of the other queues. So if you're on a server, if you're in a room with, say, 10 servers and 3 of them are dead, you're not going to lose your connectivity to the other 7 servers. And this is really much more elegant than how this looked in Dendrite before, which is where if you had a few servers that were slow or decided not to respond, or the connections timed out, the whole thing just fell over. And that was probably just a product of the fact that it hadn't really been tested all that well in real federated environments. We use the same integration test suite from Synapse called SciTest at the moment to do all of our sort of compliance testing for Dendrite. Not only does this tell us when things go wrong, but it also gives us a bit of a measure about how well we're doing. And at the moment, as of today, I can say that on the client test suite, we hit about 33% compliance. On the federation test suite, we hit about 26%. And these numbers are steadily going up all the time, to be honest. Development has really picked up in the last 6 months. And these numbers are looking a lot better than even they were 6 months ago. But it does show that we still have quite a way to go. Things that we've still got.
I ask something very quickly there.
Sure.
Sorry, Neil. 26% on the Federation API compatibility, but you're still able to, federate with the latest room versions, for example. So that seems like you actually do a lot with only 26%.
It is quite a lot with 26%, and it's maybe not the best measure insofar as that we have a lot more tests for some things than we do for others. So there are some really obscure examples for this, but like for instance, we lose, I think, on 5 tests just by not supporting room upgrades. But room upgrades have a whole suite of tests of their own, which various other things don't have. So it's not necessarily an amazing measure, but it does show that it's a bit of a path towards where we want to be.
Surely we need to split side tests down into different kind of classes of tests so that the figures look better, if nothing else. So we've got the kind of core functionality of what I need to be able to even send messages, and then the more exotic stuff like E2E encryption and even room upgrades could be kind of tier 2 or tier 3. I think it might make people feel a bit happier, and because yeah, I mean 26 or whatever % looks bad, but in reality it really is usable.
Yeah, there are some groupings with the test, but they're fairly wide nets, to be honest.
Fair enough.
But yeah, still to do. We don't have anything with end-to-end encryption at the moment. That's a really big thing, especially now that Riot tries very hard to make all new direct chats use end-to-end encryption by default. We don't have any of the endpoints in place for that yet. That's likely going to warrant an entire new component just to manage keys. Room upgrades, something I mentioned there, that's another fairly important user experience thing that we will need to accommodate fairly soon, not least because someone else can initiate a room upgrade and you're just sort of stuck with it. Read receipts, presence, those are just sort of gloss things that we don't really implement at the moment, but would be important for final user experience. And device APIs as well, which has a security component there because it's helpful to know whether someone else has signed into your account, or you can go and clean up your own sessions, maintaining account security. So there's no shortage of things still to do, but this is basically where we are, and I'm happy to show actually that Dendrite is running and usable, and I'm speaking in the channel with it. And that's pretty much it.
Awesome.
That's ace.
I think that's the first time we've ever actually had a talk about Dendrite, or even evidence that it really exists outside of a couple of random little tweets and the conversation in #Dendrite over the years. So it's kind of its first big public debut.
Yes, can confirm it's alive.
Oh, and you're even waving in the room, and it's working. Amazing. I saw Keegan was lurking in here too, who's one of the original developers on Dendrite, who has also come back to the fold to hack on it over the last however many months. And was there some rumor of trying to do a dangerous demo on it?
Dangerous demo, yeah, sure. Let's give it a go. Can you guys hear me?
We can.
Yeah, we can hear you.
A little bit
Wonderful. A little bit muffled. Oh, it's stupid. Okay. Can you see?
You saw me
my
briefly.
screen? Can you see my screen?
Yes, we can.
Wonderful. So p2p.riot.im. If you go to that in Chrome or Firefox and not in an incognito tab, and then wait approximately 10 seconds and then click explore, you should see a bunch of rooms, which will be these 3 rooms. And if you join the Open Tech Will Save Us room, that would be very good. And
So
I'm going
this
to talk
audience participation demo.
Yes, always.
Quick, everybody, come crash Keegan's demo. I am.
Yay. So you can see here that there's a bunch of HTTP requests coming and going here. In fact, I'll probably see lots more here as people, yeah, there you go. People are joining the room, so you can see lots and lots of Federation traffic. And basically, I just want to talk a little bit about how this works very, very briefly. Thank you, Matthew. So I'll start at the beginning, which is there's a binary which you can generate some WebAssembly for, which is Dendrite.js. And this sets a whole bunch of the config, hardcodes a whole bunch of database files, which I'll talk about very briefly in a moment. But the important thing is, there's a few important things, is how does this server receive, like how is this Riot Web even talking to Dendrite? I mean, you finally can compile it for WebAssembly, but how does that work? The gist of it is there is a little thing called JS server, which I sort of see. Here we go, JS server, listen and serve. And if you just look at here, all this does is, which is not particularly clever, is it defines a global in JavaScript land and sets a function called onRequest from JS. And then if you look at what this does, this basically then returns a promise and then handles the actual request. And that then feeds through to normal HTTP server requests. So that's how we receive and respond to requests, both on the client server API. For Federation, it's slightly different. Federation involves this, creating peer-to-peer nodes, as well as using a custom peer-to-peer transport, which we then replace when we create a custom federation client and everything like that, which basically the peer-to-peer aspects of this uses libp2p, and it uses the JavaScript version of libp2p, which I'll talk about briefly in a moment. And the databases, because of course this is all running in a browser, it's not using IndexedDB, not yet anyway. These databases are all in-memory databases, but they're all running in service workers. So what actually happens when you specify this database file is we have our own SQL driver here, which is this library here, which I will briefly show people, not there, here, which is this, which is basically just as a database SQL driver, which again does the same trick that the HTTP server does, and registers some, not that one, registers some global variables effectively in JavaScript land, which then is used by SQL.js, which is what's the word? WebAssembly version of SQLite 3. So we can use almost the same SQLite, well, we can use identically the same SQLite code for peer-to-peer in the browser as we can for people running SQLite on the server, but like not in the browser. But you can't. You have to use different database drivers, because obviously one of them is talking to JavaScript, and the other one is talking to the native lib SQLite C drivers, C library. Sorry. The other thing we're doing is peer-to-peer stuff. So this is piggybacking off libp2p, and again it does the same trick of registries and globals, and that's all then just shunted through to libp2p. I'm not see if there's anything interesting there. Yeah, some peer infos and stuff. They're all using ED255 or 9 keys as peers, as you can probably tell, which hopefully there's a few more people here now. Yes, there are. So these are all ED255 or 9 keys. And these are the same, we use the same key for signing events and stuff as well, which is actually really nice, because it means that you don't need to fetch keys at all, because you can just take the domain and just use that as the key instead. So there's a few nice things that you can get with peer-to-peer. The one final thing that I will finish with is that this is all going via a WebSocket server. This is how the actual peer-to-peerness is being done currently. So on rendezvous.matrix.org, there is a WebSocket star server, which is a libp2p thing, which is acting as a relay server. So your messages go to there, and then from there they go to your recipients. We are hoping to change that in the near future, so it uses WebRTC, so there will actually be kind of more point-to-point communication being done here. But as this is just a demo at the moment, it is not currently doing that. And yeah, that's basically it.
Awesome. P2P demo almost working. It did explode after about 15 people for me, so I'm not sure.
Well, someone's typing, so it's not that bad. Not been typing forever.
Yeah, it's for me too, and for other people, I think.
Yeah.
Sorry.
It's both of them we've got so far. I think we're just going to keep doing the P2P demo until it can scale up to an entire audience of hundreds of people being thrown at it.
It took a long time, but I was able to get it.
Oh, what was that?
You have until next year for them to actually get 500 people into the room.
This will be our recurring theme for FOSDEM, that we do a demo 1 year and then come back the next year and it actually works. A bit like we did with cross-signing E2E by going and showing it ready real soon now, guys, and then literally turned up the next year and did the same demo again, except this time it's a reality. Cool. Thank you, Keegan, for the demo, and thank you, Neil, for the presentation and the talk. Do we have any questions from anybody, Ben, out there?
We do. Actually, Keegan answered a few of them in the room, but maybe we can do them on the video as well. So Timo asked, how much overhead is there in putting everything into components when you're using Dendrite as a monolith?
The NAFCA question.
Yeah, so this is, yeah, exactly.
Okay, well, I mean, I can read what I wrote.
Yeah, I know. I mean, it's a video.
Sure. Basically, we haven't measured it per se, but in monolith mode, we're obviously using Kafka instead of Kafka, and there's internal HTTP APIs that Neil was talking about. Those are actually done as direct function calls at the moment. There's no serialization through to HTTP.requests, so there's effectively no overhead there. But for Kafka, it does involve a database hit to persist the Kafka event into the right position in the topic stream. So that will have some overhead associated with that, which may or may not be more than just writing it straight up to a Kafka broker. So,
okay.
And presumably we can optimize that anyway and have it not hit the disk or have different levels of persistence if you want.
Yeah, I mean, in all honesty, I will be highly surprised if that ever becomes a sufficiently high enough bottleneck. Like, I just don't think it will be. But we can profile it and see if it does.
I do love the idea that you might end up with a kind of back pressure problem happening with one part of the app busy channeling information into the database and another bit of the same app falling behind on processing it. It's like literally a multi-server system all wedged into one process for the sake of it.
Well, this is the thing. We have to be careful of that when it comes to the internal HTTP APIs, because obviously those are synchronous. But as far as Kafka goes, the components will just pick up whatever it is whenever they get it. So it's, it's different problems in different places, to be honest.
I think it's a cool idea, honestly, that the monolith works as well as it does, and that whilst we originally designed Dendrite to literally run matrix.org and scale up to tens of millions of users, the fact that it also scales all the way down and can be used for peer-to-peer and embedded stuff, and will clearly end up being a library that Eugen can embed into Mastodon for doing all of his DM and stuff, is clearly the way forward. Any other questions out there?
So this one was also already intercepted by Keegan, but the question from Nico was: Is there one room server per room, or one single room server per home server? So
single room server per home server at the moment.
Right.
But the whole point, though, is that they can scale horizontally, right? And we can put different rooms and different sets of room servers for the same server.
Yeah, precisely. So at its finest granularity, you would have one room server for just one room. So if Matrix HQ was super busy, and one process would be just enough to manage it, then that's cool. You can do that.
So I was having a shower thought over the weekend about account portability and MSC 1228, which is the key-based identifiers allowing account portability in Matrix, and had the realization, which was a bit of a kind of double rainbow moment, if you will, that with multiple room servers inside Dendrite, and indeed horizontal scaling in general in Dendrite, you almost could end up with a whole cloud of Dendrites, which you could move your account between via account portability. So you kind of end up with sharding on a supercluster basis. So you could literally have 10 independent home servers and basically do load balancing between those servers by just moving the accounts between them based on where you wanted the accounts and their rooms to end up being. So a bit like you can shard the overall rooms on your server between different room servers, you could shard the users between a cluster of otherwise completely unrelated Dendrites. I don't know whether this was profound or meaningful to anybody but me, but at the time it was, oh, this is interesting, because basically it gives you complete fungibility to move your users around potentially almost in real time and have that sharding. It's a kind of inverted sharding approach, where rather than figuring out how to split your users within a server, instead you go and split your servers out. You split your users outside of servers. Did that make sense to anybody? Nope. Oh well.
We'll say yes.
Yeah, I'm sure many
clear,
people understood it. So there's a couple of things here that are not strictly questions. Lots of people want jobs with Matrix, so we can talk about that in a different channel, I guess. And the other thing is Nico, who's been working on his project Masquerine. So he's working on a home server written in Scala, and he's basically yeah, got this same idea of the each room is managed by a room server, and he's using the actors model for that idea. So yeah, I think he may have come to a similar conclusion independently. There's been a lot of discussion in the home servers dev room over the last few weeks on this kind of topic.
Is that the same as Plasma, or is it?
Yeah, this is the same fellow. Yeah. But this is Plasma was an Elixir project, and then this is basically a re-implementation of the same ideas in Scala.
Very cool.
Yeah, it is very cool. So he's been making some progress. And there's one more question. I don't know. So is anybody running Dendrite on a phone? There seems to be rumors that it might be almost working on a phone, and if so, what database does it use is the question.
There is an ongoing project at the moment to run Dendrite on, actually embedded into Riot Android, and it's just using the SQLite database.
Okay, cool. I mean, the database is probably the least interesting part of that thing, but yeah, having it.
It's effectively the same code that we use for the FastM demo, but just embedded into Riot.
Right.
And that's one that Hilmar is doing, right?
Yes, it is, yes.
Cool. Is he using Riot X or Riot Android? Do we know?
Riot Android, because he did try using Riot X, but ran into some problems where it wouldn't sign in because Dendrite didn't implement certain features that Riot X wanted.
No, you need to get your scientist percentage up, I guess, because it would be a very strange and unusual punishment to have amazing peer-to-peer matrix, but start using Riot Android rather than Riot.
So I just got a clarification on that question. When it's WASM in the browser, it's using IndexedDB, right?
It is not using IndexedDB. It is all in memory, so you will lose your databases if you close your browser.
Could it be in IndexedDB? I mean, Riot is already doing that.
Yeah, it absolutely could be in IndexedDB. We just haven't got to that point yet.
Sure. Okay.
Watch this space because it probably will happen sooner rather than later.
Okay.
Clearly, the best way we should do persistence in the index in the worker thing is to go service worker is to just do a blunt SQL dump and literally get a string of SQL and put it in local storage. I mean, nothing says class.
I was kind of planning on just doing that. Yeah.
Precisely. Window.localstorage.db equals 1.
Except probably IndexedDB because you can store more in IndexedDB than local storage.
True.
But otherwise, yes.
Cool. So to be clear then, there's two things happening here, or at least two things. There's Dendrite running in a conventional manner with or without Kafka and using Postgres. There's Dendrite running as a WASM process and using currently nothing but in memory. And then there's Dendrite running in WASM in other locations. Just getting some questions that people weren't always clear on the differences there.
So basically you have normal compiled Dendrite for server-side environments. Which is just go build, and it kind of works and it does its thing. You can run it in Postgres, you can run it in SQLite.
Mm-hmm.
Separately, you can go allows cross compilation to WebAssembly. So using that on the Dendrite JS binary will generate a Dendrite which will work in a browser because it uses those JS globals I was showing earlier. And then separately to that, the Go compiler also has an Android. I think so. Neil might be able to correct me or not. Has a Android target as well. So as far as I'm aware, the Android experiments are basically compiling Dendrite. I guess it's the FOSDEM peer-to-peer demo, but it's being compiled with the Android target, so it will work in an Android environment. And that's it so far.
Yeah, I think possibly they might be using GoBind as well, just to make the bindings for whether it's Java or Kotlin or whatever it is. But yeah, effectively using the Android target.
Yep.
Dendrites everywhere, including Plan 9 and ARM.
Okay.
I'm going to try that one of these days.
Good luck with that. We must be out of time, Ben.
Oh, yeah. We're actually, do you know what? It's almost exactly 8 o'clock where I live. So I think we should say thank you very, very much to everybody involved. We had Mike from Mozilla. Thank you very much. We had Eugen, who's from Mastodon and the inventor of Mastodon. So thank you very much. And then everybody involved in Dendrite. Neil, thank you for putting together a presentation. And you and Matthew and Keegan have been doing us a good demo. So thank you very much.
Thanks, everybody.
Thank you, everyone.
Have a good evening.
Bye-bye.
Bye.
Bye.
Bye.